Our last section in Unit 2 is going to involve quadratic systems. So what we're going to do is we're going to graph two equations, and we're going to see either where they intersect, or if we're looking at inequalities, where their shaded regions overlap. So in problem number 1, we are given what are the solutions of y equals negative x squared plus 5x plus 6 and y equals x plus 6. So in this case, we've got a quadratic equation and we've got a linear equation. So we can expect to see a parabola and a line on our graph. So let's go ahead and start with that quadratic equation of y equals negative x squared plus 5x plus 6. We know that our a value is negative 1, so that means we've got a reflection. The y-intercept is 6, and then the x-intercepts, we're going to pull that negative out, and then we're going to factor the x squared minus 5x minus 6. When we do that, we get x minus 6 times x plus 1, and that means that our x-intercepts are at 6 and negative 1. Then we do our axis of symmetry. Since this is standard form, we're looking at negative b over 2a. So negative 5 over 2 times negative 1, or negative 5 over negative 2, which gives us 5 halves, or we're looking at 2.5, which coincidentally is halfway in between 6 and negative 1. Then our vertex, plug that 5 halves into the original equation and work that down, and you end up with 5 halves, 49 over 4. So we're looking at an axis of symmetry of 2.5, and then the y value for the vertex is going to be at 12.25. Fortunately for us, graphing the linear equation is much easier. So we see we've got y equals x plus 6, so that means our y-intercept is at 6. Our slope is 1 over 1, or negative 1 over negative 1, and then we can just go ahead and connect those points, and there you have that. Going back into the parabola, we've got 2 points so far that we know. We've got 3 points. We've got our y-intercept, which we know is 2.5 units away from the axis of symmetry. So if we go 2.5 units the other direction, we can also put a point at 5, 6. That leaves us with just 2 points to find. So I'm going to choose the point 1 and 4, or points 1 and 4. And since these are an equal distance away from the axis of symmetry, they should give us the exact same y value, which you can see they do, which is y equals 10. Once you've got those last 2 points, we can create the xy chart. And once we've got the xy chart done, we can graph them. And you can see that the line and the parabola intersect at the points 0, 6, and 4, 10. So those are going to be the solutions to our system of equations. In problem number 2, we're going to solve a linear quadratic system using substitution. So we're given the quadratic equation y equals negative x squared minus x plus 6, and the linear equation y equals x plus 3. Since the linear equation is already in slope-intercept form, we already know the value for y is equivalent to x plus 3. So we're going to slide that over and in for the y in the quadratic equation. Now I've written this with the quadratic first and the linear second. You can do either or. So what I see is I've got that negative x squared. I don't like that negative hanging out in front of the x squared term. So what I want to do is I want to take the quadratic side and I want to move that over to the linear side. And the reason why I'm going to move everything over is because I've got a trinomial. And since I've got a trinomial, I want to make sure that everything is over on the same side so that I can do factoring. So I get 0 equals x squared plus 2x minus 3. And then we factor that down to x plus 3 times x minus 1. Use the zero product property to get us to x equals negative 3 and x equals 1. We're then going to take each of those values, and I'm going to plug it back into the linear equation because that's the easier one to use. And when we do that, we get y equals negative 3 plus 3, and then y is equal to 0. So when x is equal to negative 3, y is equal to 0. So that's our first point. Then on the second one, we had x is equal to 1. So when we plug that into the linear equation, we get 1 plus 3, so y equals 4. So our second point is going to be when x is equal to 1, y is equal to 4. If we were to go ahead and substitute these into the quadratic equation, we would get true statements on both sides. In problem number 3, we're going to solve a system of quadratic equations using whichever method is best. And in this case, we're going to do combining like terms on the same side of the equation. So we're given negative x squared minus x plus 12, and then x squared plus 7x plus 12. And both of those are set equal to y. So if they're both equivalent to y, then I know that they're both equivalent to each other. So I can set them equal to each other. So we get negative x squared minus x plus 12 is equal to x squared plus 7x plus 12. Since I've got these equivalent expressions, I am going to go ahead and move the one on the left side because it has a negative 1 as the lead coefficient, and I'm going to move that over to the right side. So when I do that, I get 0 equals 2x squared plus 8x. Those 12s ended up canceling out, so now I'm only left with an x squared term and an x term. So looking at this, the first thing we can do is GCF. We've got a 2 that we can divide out of both the 2 and the 8, and we've got an x that we can divide out of both the x squared and the x. When we do this, we're going to be left with 2x times x plus 4. Now you've been told in the past that if you just have a number sitting on the outside of the factor, you can throw that away. Here we don't just have a number sitting on the outside of the factor. We have an x value. So that means it's part of our solution. So we're going to have to set both of those factors, the 2x and the x plus 4, equal to 0. So when we do that and use the zero product property, we're going to divide that 2 out from underneath that x. And anytime that you divide 0 by anything, you're going to get 0. So x is equal to 0. And then x plus 4 equals 0 gives us x equals negative 4. Now again, take those values that you just came up with and plug them into one of the equations. So I'm going to use the equation that has the positive x squared for the first one and also for the second one. So we're going to plug in 0 for x, and when we do that, we get 0 squared plus 7 times 0 plus 12. And on the one on the right, we're going to plug in negative 4 for x. So we get negative 4 squared plus 7 times negative 4 plus 12. Once we start to simplify that down, 0 squared is 0, 7 times 0 is 0, and then just bring our 12 down. On the second equation, negative 4 squared is 16, 7 times negative 4 is negative 28, and then just bring that 12 down again. Now we can just combine all of our like terms. So 0 plus 0 plus 12 is 12, and then 16 minus 28 plus 12 is 0. So what we get is when x is equal to 0, y is equal to 12, so that's the point 0, 12. And then when when x is equal to negative 4, then y is equal to 0. And so our solution there is negative 4, 0. For this final problem number 4, we're going to be looking at solving a quadratic system by graphing. And this time we've got inequalities. So we've got y is less than negative x squared minus 9x minus 2, and y is greater than x squared minus 2. So again, what I want to do with this is I want to treat these as equations first and inequalities at the end. We can do our shading and all that stuff later on. The first thing we need to do here is look at our a value on the first inequality. So that's going to be negative 1, which gives us a reflection. Our y-intercept is at negative 2. And then when we plug in, or when we look to factor the x-intercepts out, we're going to see that we can't factor this. It's going to need the quadratic formula or completing the square. So it's really not worth finding the x-intercepts on this. So we're going to move on to the axis of symmetry, which is negative b over 2a. So we get negative 9 over 2 times negative 1, which ultimately gives us negative 9 over 2. When we plug negative 9 over 2 back into the inequality, we are going to get 77 over 4 is the y value. So this is going to be 19 1/4. So you can see that what I've done is I've adjusted my graph so that each tick mark is worth 2 on the y-axis. With the x-axis, I have also adjusted that as well so that we're looking at tick marks of 2. So the graph is going to maintain its shape because we've got both the x's and the y's are going by tick marks of 2. When we look at the second inequality, we're going to again take a look at that a value, which is 1. So we get no stretch compressor reflect, which means that this one opens up. We have a y-intercept once again at -2. So you can see that -2 came up, and it's underneath the -2 from the other one. X-intercepts, it would be a square root, so we're not going to worry about that. And then the axis of symmetry is at 0. So the vertex is going to be 0, -2. Then we're going to substitute values into the equation for x and find the resulting y value. So we've already got a couple of values already for the first inequality. So I'm going to choose -6 and -3 to plug into that first inequality. And when I do that, y is equal to 16 both times. So we go ahead and plot those on the graph. And then we're going to take a look at the second inequality. On the second inequality, I need 4 points. So I'm going to choose -2, -1, 1, and 2 because my axis of symmetry is already on the y-axis. When we plug in -2 for x, we get y equals 2. When we plug in -1 for x, we get y equals -1. 1 for x gives us -1 for y, and 2 for x gives us 2 for y. So when we go to graph these, we're going to use dashed lines because both of these inequalities are less than and greater than. They have no equal to component on them. So you can see we've got the dashed lines on our graph. Now the last thing we need to do is choose the test points in order to figure out where we're going to shade. So the test point that I'm choosing for the first inequality, the green inequality, is -4, 0. So when I do that, I plug in -4 for all the x's and I plug in 0 for the y. So that leads us to negative times -4 squared minus 9 times -4 minus 2. On the purple inequality, or the second inequality, I'm going to choose 0, 0. It's always the easiest. So then 0 is greater than 0 squared minus 2. When we start working these out, going back to the first inequality, you get -16 plus 36 minus 2. And for the second inequality, you get 0 minus 2. Combine like terms, and you get 0 is less than 18 on the first inequality. And that is a true statement. So since that -4, 0 is inside of the parabola, we're going to shade everything inside the parabola. On the second inequality, we get 0 is greater than -2, which is also a true statement. And since 0, 0 is inside of the parabola, we're going to shade inside of the parabola. You can see anywhere that those two parabolas intersect, that's where the solutions are going to be, with the exception of on the parabolas themselves.